Hello, I'm Carlos Suarez, and this is the CRS channel. In this video, we're going to continue with our geometry problems. I'm going to start with this problem. It says, prove that an inscribed angle in a semicircle is a right angle. Here we have a semicircle A, P, B, with center in C. We have CA equals CP equals CB, and those are the radii of the semicircle for this exercise. And we have angle APB. This angle has vertex at P, which is on the semicircle. It has sides PA and PB, with the endpoints of those sides of the angle being points A and B, and they are both on the semicircle. So angle APB is an inscribed angle in semicircle APB. Okay, now you can see that we have three triangles: triangle APB, triangle APC, and triangle BPC. Now, as you can see, since AC equals CP and is also equal to CB, we have that triangle APC is an isosceles triangle, and so is triangle PCB. So that means that angles CAP and APC are equal, and we will identify them with the letter alpha. We also have that angles CBP and BPC are also equal to each other, and we will identify these angles with the letter beta. Okay, we have then that angle BCP equals pi minus 2 beta, and we have that angle ACP equals pi minus 2 alpha. We also know that angle BCP is equal to, and the sum, okay, I'm going to repeat it, angle BCP equals the sum of angles CPA and PAC. That is, pi minus 2 beta equals alpha plus alpha. That means that pi minus 2 beta equals 2 alpha. Also, we have that angle PCA equals the sum of angles CPB and PBC. That is, that pi minus 2 alpha equals beta plus beta. That is, P minus 2 alpha equals 2 beta. So, having that, we can say that pi minus 2 beta equals 2 alpha. That is, that pi equals 2 beta plus 2 alpha, which is this we have here. We also can say that pi minus 2 alpha equals 2 beta. That is, pi equals 2 alpha plus 2 beta, again what we've got here. So if pi equals 2 alpha plus 2 beta, that means that alpha plus beta equals pi halves. Now alpha plus beta equals the angle APB, which is the inscribed angle in semicircle APB. So we have proven that the inscribed angle in a semicircle is a right angle. Okay, now we go to the next problem. We have that the length of the segment traced from a point on a circle. Here we have the semicircle. We don't need to draw the whole circle. It's enough with drawing the semicircle here, which is shown in the figure. So the length of the segment traced from a point on a circle, this is the point on the circle, and we have that the segment traced perpendicularly to the diameter. Here we have the diameter. This is the perpendicular to the diameter. So the length of that segment that has been traced from the point on the circle to the diameter, which is this segment here, the length of which is given by h. So it says that that length h is equal to the geometric mean of the two segments into which the diameter has been divided. So the diameter has been divided into segments L1 and L2, and the geometric mean of the two segments is equal to the square root of L1 times L2. So we have to prove that h equals the square root of L1 times L2. Okay, so we know that being d, the diameter of the circle, we know that d equals 2r, where r is the radius of the circle. So we have that L1 plus L2 equals d, that is L1 plus L2 equals the diameter of the circle. The diameter of the circle, d, equals 2 times r. That means that it's equal to 2 times the radius. Now, we have that L1 equals r, that is this segment here, plus this segment here. Now, this segment here is one of the cathetae of this right triangle here. The other one of the cathetae is h. The hypotenuse of the right triangle is r. That means that this segment here is equal to the square root of r squared minus h squared. This is the application of the Pythagorean theorem. So L1 equals r plus the square root of r squared minus h squared. So we have that L1 equals d halves plus the square root of d squared fourths minus h squared. So we send this one to subtract and we square that, so that we have that L1 minus d halves squared equals this square root squared, and that square root squared is d squared fourths minus h squared. So we have that expanding this square, we have that L1 squared plus d squared fourths minus d L1 equals d squared fourths minus h squared. Canceling these two terms, we have that L1 squared minus d L1 equals h minus h squared, and then that h squared equals dl1 minus L1 squared. So d equals L1 plus L2, we replace that here, we multiply L1 times L1 and L1 times L2, and we have that L1 squared plus L1 L2 minus L1 squared equals h squared. We cancel out these two terms, and we have that h squared equals L1 times L2, and therefore that h equals the square root of L1 times L2. Okay, so there we have finished these two geometry problems. The next video will be about another geometry problem.